Good morning. Today our lesson is about work and power, but before defining work and power, we are going to talk about force. What is force and when do we speak of force? As we can see in the figure above, I have a horse that is pulling the cart, so it is exerting a force in order to pull the cart. Also here I have a boy that is stopping the ball from movement, so we say that the boy is exerting a force in order to stop the ball from movement. Also here the ball is changing its direction. How? Because the boy is exerting a force in order to change the direction of the ball. Here the paste is changing in the shape, as you can see, or is changing its shape. How? Because the boy exerts a force in order to change the shape of the paste. So we call force any action capable of producing or stopping the object's movement, of changing the direction of an object's movement, of changing the object's shape. Now I want to define work, but before defining work, we need to define or to know the meaning of the application point. The application point of a force is the point where this force is exerted. For example, here this is the application point because at this point the force is exerted. As you can see, the boy is pushing the trolley. Of course, he is exerting a force, and as you can notice, the application point of the force is displaced. It is moving from one place to another. Here also the boy is pulling the table, so the application point of the force is displaced. Here the boy is lifting up the bag. Also the application point of the force is displaced. So we say that these children are producing a work or a physical work because the application point of the force is displaced. What about this case? In this case, the boy is trying to push the car, but it doesn't move or it is not moving. So the application point doesn't change here. So can I say that I have work here? Of course not. In this case, we don't have a physical work because the application point doesn't change. So when a force exerted on an object displaces its application point, it produces a work called physical work. So the application point should be displaced in order to have. Now I want to talk about power. What is power and what does the power depend on? As you can see here, I have two children. They are trying to lift up a bag of mass 10 kilogram to the same level, which is 9 meters. Here it takes me 60 seconds to lift up the bag. So the child lifts up the bag in 60 seconds. While here the child lifts up the bag in 30 seconds. So the child of drawing 2 produces the same work in less time. He has a bigger power. Why? Because he produces the same work in less time. Now here, as you can see, the girl is lifting here 2 bags of mass 20 kilogram. More than the mass lifted up by child 1. I lift up 2 bags within 60 seconds. The child of drawing 3 produces a bigger work within the same time as in case 1. His power is bigger than in case 1. Why? Because he is lifting up a bag of mass 20 or 2 bags of mass 20 kilogram. Power depends on work and on time. As time decreases, the power increases. As work increases, the power increases. Now to calculate power, I should use a formula, which is power equal work divided by time. These are the symbols. P is the symbol of the power. W is the symbol of the work. T is the symbol of the time. Of course, I have the units. The unit of the power is watt. The unit of the work is joules. The unit of the time is seconds. So the power corresponds to the work produced per unit of time. It is equal to the work produced divided by the time taken for producing it. The power gets bigger when the work produced is bigger and the time needed for producing it is smaller. And now we are going to solve this exercise in order to use the formulas that I explained. And now we are going to solve the exercise on page 131. Calculate work and power. A child having a weight of 200 Newton goes up the stairs from the ground floor to the second floor, crossing 6 meters in 30 seconds. Before we start solving the exercise, we need to write the given. Always do this in order to solve it easily. Of course, he said that the weight of the boy is 200 Newton, so the force is 200 Newton. He said that he crossed 6 meters in 30 seconds, so the time is 30 seconds and the distance is 6 meters. So now he said he produces work, okay? Calculate his work. When he says calculate work, I should write the formula. Work equal force times displacement, and of course we write the unit joules, Newton, meter. So I start writing work equal, how much is the force? It is 200 Newton. 200 Newton times displacement is 6 meter. So the answer will be 1200 joules, of course, because the unit of the work is joules. So to calculate the work, I multiplied the force with the displacement. 200 times 6. Now he asked me to calculate the power. I use the formula of the power. Power equal work divided by time. The work is 1200 joules. I calculated it, so I write the formula. Power equal work 1200 joules divided by time. The time is 30 seconds. Okay, the answer will be 40 watts.